Welcome back to Ashutosh Academy. Now we are going to solve this second question based on first law of thermodynamics. Okay, so it says that moles has 2. Okay, that means it's given that 2 moles of an adiabatic gas is kept in a cylindrical container fitted with a movable piston. Okay, obviously first law can be applied because the piston can move. So the first part says, it's really simple. I'm going to write the formula first and we'll solve it for each and every part. Okay, the formula is dq is du plus dw. So the first part says 20 joules of heat is given to the system, means dq is positive because it is given to the system, and it's found that the system does 30 joules of work. Estimate change in delta u, you need to calculate. So delta u plus 30, obviously work is done by the system, so it will be positive. So the answer of delta u will be minus 10 joules. This is the change in internal energy of the gas. And what does this negative sign show? It shows that the temperature has what? Decreased or increased? Decreased for the gas. Okay, B part. B part is 70 joules of heat is given to the system. Again, 70 joules of heat is given to the system. Okay, again positive because it is given, and 40 joules of work is done on the system, means this time we are moving the piston, and if we are working, that means it's negative work done. So minus 40 plus change in internal energy, this time change will be 110 joules. Okay, C part. I hope you are finding it easy. Now the C part is very important. Okay, now what is an adiabatic process? You will be seeing what an adiabatic process in my upcoming videos, but for this particular question you should know that for adiabatic process, delta Q is always 0. This is important. For adiabatic processes, delta Q is always 0. So we can directly apply this first law. It says, obviously delta Q will be 0. Let's read from the question. It says, if adiabatic process is done where 30 joules of work is done by the system. 30 joules of work is done by the system. Since the system is doing work, it's good. Positive plus delta U. So delta U will be negative 30 joules. Okay, let's do the fourth part. Fourth part is if piston is held fixed. And what does this mean? If the piston is held fixed, if the piston can't move, then obviously work done cannot happen in the system. Then dW will be 0. And it says that 10 joules of heat is rejected by the system. Means system is giving out heat to the surroundings. That means it is negative, because when we supply the energy, when we give the heat to the system, that is positive, and if the system is releasing the heat, that will be negative. So minus 10 is equals to delta U plus work done as 0. So not work done as 0, so we will get du as minus 10 joules. Okay, now the fifth part. Okay, fifth part is a little bit tricky again, because you don't know what is the isothermal process. Okay, so again you need to know that for an isothermal process, temperature is always constant of the system. Okay, and if temperature is constant, that means you can't do any kind of work. Work done is 0. So we again apply dq is du plus dw. Work done is again 0. So this work done term becomes 0. So we are left out with du is equals to dq, and since 50 joules of heat is rejected by the system, that means it is negative. Okay, so this is our answer. Next part. Next part is also based on another kind of thing. It says the internal energy of the system, of a thermodynamic system, is increased. Means delta U should be positive. Obviously if it is increased, so it will be positive. Next, and 30 joules, by 30 joules, and the system performs 30 joules of work. Okay, system is performing the work, again it is positive. So you get delta Q is equals to delta U plus delta W, so it will be 60 joules. Okay, now we have the last part. It says 45 joules of heat is rejected by the system. Obviously when heat is rejected, then it should be, what should be the sign of it? Negative. Okay, then 50 joules of work is done on the system, means we are working, so it is U here, so minus 50. And what will be the change in internal energy? It will be 5 joules. Okay, so this brings us to the end of this question. Thanks for taking out time to watch my videos, and please do watch my other videos. Subscribe to my channel. Thanks.